Assalamualaikum and good day to all panel. Welcome to the presentation entitled PaMoMo Paper Molecule Model. First, let's introduce our team. I am Hanis MY with team member Dr. Melissa, Dr. Hazlina, and Dr. Nohana. We are from Faculty of Science and Marine Environment, University Malaysia Terengganu. Here is the layout of the presentation. The first one is describing PaMoMo. The second one is the innovation practicality. The third one, student involvement. And finally, project potential. So what is PaMoMo? PaMoMo is molecule made easy with just paper. Shown is boron trifluoride molecule, BF3, with numbering of fluorine atoms, and arrow for better understanding when operations are carried out with the specific molecule. So this is BF3 PaMoMo. And another example shown here is water with its symmetry operation, which can be seen reflected using a mirror towards the molecule. There are several more examples of symmetry operation that can be carried out, which are rotation and inversion. Why use PaMoMo? To have hands-on experience symmetry operation towards the molecule, and when we can carry out this symmetry operation, we can classify the molecule to its own point group, and then finally, it is an easy and creative learning during lecture and very useful when there is no internet sources or software sources to learn this symmetry operation and point group. For creativity and originality, it is inexpensive, where you just need paper, scissors, and glue, and also easy to create, where you can create 2D and 3D molecules based on the molecular shape. Let's go to the second one, innovation. Of course, there are software or online simulations. However, there is limited imagination, and you require software installation and also internet. Even though it is easy, there are some symmetry operations that require further imagination to understand about the symmetry operation. So, the disadvantages of the software or online simulation is its limited application, where it's time-consuming and cost, require additional processors to perform certain symmetry operations. While by using PaMoMo, we can maximize the understanding, where the PaMoMo is easy and reusable, and students can participate during class by making similar molecule models, especially for Gen Z students, where they require hands-on. So, symmetry operations can be performed directly towards PaMoMo. As for innovation sustainability, this can also replace conventional assignments, where assignments for students can be made and they can record a video on how they classify molecules using PaMoMo, or they can do documentation about classifying a point group of certain molecules using PaMoMo. And it is also suitable for face-to-face or even online teaching, and since students can do the molecules anywhere they are. And then it is real than simulation or software or even computational approach. The third one is student involvement, where it involves course learning outcome and also surveys. So this PaMoMo has been applied in molecular spectroscopy, AIM 4106 for Bachelor of Science, Chemical Sciences, third-year students, and focusing on ClO3, deduce molecules or objects into their point groups based on the symmetrical elements and predict their physical properties. So these are the steps to process point group classification. First of all, choose the required molecule based on its shape, and then for form the symmetry towards the molecule, and finally, students can classify the point group from the symmetry operation that they have listed out in step 2. So impact towards students before PaMoMo are applied during class. This is the performance of APY12, and after applying PaMoMo, so it has increased from 73% to 91%. And a survey also has been carried out towards symmetry knowledge before and after introducing PaMoMo. So before, around 40% of students stated that they have this lower than 50% knowledge of symmetry elements. But after applying PaMoMo, it has increased from 14% to 80%. And this increment is more than 50% increase of a student understanding. And there is another survey asking about is molecular symmetry is an interesting topic to learn with PaMoMo, and 97% students agreed. And 89 students also agreed that PaMoMo is a helpful tool to be compared with other software like 3D or certain websites. And here are the feedback. So the students love using PaMoMo and like the teaching method that has been carried out. And then here's another feedback where they agree with the method and agreed that PaMoMo is a good idea to further understand the symmetry operation and also classifying the point group of molecules. And finally, the innovation potential. So this can be expanded to other related course or lab in high school or even industrial related. And then it can be extended to various 3D models such as using plasticine, polystyrene, straw for more real hands-on approach. Of course, we need to look at the cost, and low cost or no cost is preferable. An appropriate toolkit can be further developed with this PaMoMo approach. And as for other planning, we are planning for copyright in the process, and the extension or further extension of this PaMoMo are currently carried out in this semester. With that, thank you so much for your attention. Assalamualaikum.